Hello friends, welcome to my channel. Let's have a look at a earlier problem, that is problem 203, remove linked list elements. So this problem actually is a similar problem to today's daily challenge problem. So we choose to look at this problem again. So given the height of a linked list and an integer value, so remove all the nodes of the linked list that has node value equals to this value and return the new height. So this is the statement of the problem. So here are three examples. So the second example is sort of trivial because the linked list is a null list. And the third example is another extreme. All the node values are equal to the value to be deleted. So we are resulted in a null linked list. So the first one is sort of the generic case. So after we delete the 6, so we're going to have 1 pointed to 2, 2 pointed to 3, and 3, 4, 5, and 5 is the last node, and 5 points to null. So with that said, let's look at the constraints of this problem. First, the number of nodes in the list is in the range 0 to 10 to the power of 4. So in other words, this linked list can be null, as demonstrated by example 2. Secondly, the node value is non-negative, actually straight positive, and bounded above by 50. And the value itself is in between 0 and 50. So that's the problem constraint. With that said, let's look at our analysis. So here our treatment is the following. So we are going to use a dummy node to help us do the linear scan. So we could maintain a pre-node so that we could do repointing conveniently during the process. So here let's look at a walkthrough of example 1 to digest the procedure. So here the linked list have height 1 and the value is 6. So we are going to delete all nodes with value field being 6. So because the value, the given integer, is in between 0 and 50, so we could use a dummy node, say with value -1, to connect with the height. So then if we connect the dummy node -1 with the height, so this is the linked list, right? So we can initialize a previous to be the dummy node -1 and the current to be 1. Then we continually scan the linked list. So basically it's a while loop. So we're going to check if the current value equals the value we're going to delete or not. If not, we're going to reset, push the previous to be the current and the current to be the next, and continue. So if we look at 2, right, so the current value is still not 6, so we reset previous to be the current 2 and the current to be the next 6. So in this case, the current value equals 6. So we continuously moving forward until we meet a non-6 node. So here the non-6 node we meet is 3. So then we are going to set current to be 3 and repoint the previous to point to 3. So we have -1 and 1. So this is the previous 2, right? We're going to originally it points to 6. So now 2 points to the current 3, and 3 points 4, 5, and 6. So next we continue, right? So current is 3. So 3 does not equal to 6. So we are going to reset previous to be 3 and current to be next. That is 4. So 4 still does not equal to 6. So we move forward. Previous to be 4 and the current to be 5. And then 5 is still not 6. So we are going to set previous to be 5 and the current to be 6. So now we meet a node with a value 6. So we continuously moving forward until we meet a non-6 node. So in this case, such a node is null. So in this case, we are going to set previous next to be null, and the process completes. So actually, this problem in some sense is still not generic enough. For example, we have 1, 2, 6, then we point 6 to 6 again, 6 again, 6 again, then to 3. So similar to the situation in example 3. That's the most generic case I would say. So with that said, and this walkthrough, I think it's sufficient enough to write a code or write a solution. So with that said, let's look at the code. So first, I'm going to introduce the dummy node. So the dummy node is a list node. So we're going to have a value field to be -1. So this is to distinguish the value with the value to be deleted, right? So because this value is not negative, so I set a value to be negative here. And then the next to be the head. So this way we instantiated a dummy node, and also we connect the dummy node with the head. So with that done, so we are going to have a previous, that is a dummy, and we're going to have the current is the current head, and then basically it's a while loop, while current. In between, we're going to check if current value equals or does not equal to the value to be deleted. If it's not, so this is the easy case, so we just need to push previous to be current and the current to be current next. So this is the if condition. Else, in other words, the current value equals the value to be deleted. So this current node for sure needs to be deleted. It's possible there are several consecutive nodes with the same value. So in this case, we need another while loop. So like in the situation here, right? So what we are going to do is while current and current value equals a value. So we first check this condition. If current is not null, so we can check its value field, right? So if this is the case, we are going to set current to be current next. So this way, as we exit this while loop, there are two cases. First, the current is null. So in other words, it's if not current. So we are going to we arrived at the end of the linked list. So we are going to set the previous next to be null, and then we return dummy next. So this is the one case. Another case is easy. So we just need to set previous next to current, and then we go to next round of the while loop. So to check if the current value equals the value to be deleted, and then if not, we push forward. So that's the code or the solution to this problem. Actually, it's a verbose translation of the above idea or procedure. So finally, we just need to return dummy next. So we can regard here as an early stopping condition in some sense, but it's not a not an early stopping condition in a strict sense, because we already arrived at the end. So with that said, so that's a format of solution. So we can do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. Yeah, that's about it for this problem, and also that's about it for this video. Thank you.